everyone, welcome to the Auburn University RFID Lab. This video is the first in a series of videos in which we will break down RFID technology and what it looks like when you implement it into your business and personal life.
This first video is just going to be a basic breakdown of what RFID technology is and where you may have seen it implemented already. We'll also be going over some keywords that will be important to know as we release more of these videos.
So let's get started. RFID stands for radio frequency identification. This type of technology has lots of use cases in many different industries. It can be used for inventory tracking, supply chain management, or just making life a little bit easier. But how does RFID work?
If you've ever crossed the finish line of a race, tracked your pet, or used an Easy Pass at a toll bridge, then you have already been the beneficiary of radio frequency identification, or RFID technology. RFID uses radio wave technology to identify items marked with a tag. RFID systems consist of three parts: a reader, an antenna, and a tag. The reader sends out radio waves, which are amplified by the antenna. These radio waves activate the tag, which then broadcasts its data right back to the reader.
So let's break down the RFID system a little bit more. First, talk about the reader. There are lots of different types of readers that can be used in different scenarios. Handheld readers are small portable readers that, as the name suggests, are operated by hand. These readers are useful for counting inventory on the store floor. Fixed readers are larger and fixed in one position. These readers can help you track inventory movement within your store. For example, large readers are often placed at the store exit to let you know what inventory has left your store.
Next, let's talk about the antenna. This antenna is required to read and transmit data for the readers. The antenna produces RF waves that are used to scan tag applications. The waves are produced in a conical pattern. An easy way to picture this is if you balance an ice cream cone in the palm of your hand. The tip of the cone represents the tighter spread of the RF wave distribution, and as the cone continues to grow up, this represents the further you are from the antenna, the weaker the waves get. So basically, the greater the spread means the greater the distance and the weaker the waves are.
Finally, let's talk about the tag. RFID tags are thin tags that are encoded with a specific code. Unlike barcodes, each product tagged can be given a specific code called an EPC. EPC stands for Electronic Product Code. This ability to be coded with an EPC is what really sets apart RFID technology. With a barcode, you can label a product as cereal, but there's no way to differentiate between each box of cereal. With an RFID tag, the EPC can tell you exactly which box of cereal you are working with. This helps streamline the inventory tracking process.
Now, you might be thinking, this sounds great. Let's get a whole bunch of tags, throw them on everything, and get to it. But there are a couple of roadblocks to RFID that the lab is currently working through.
One of these roadblocks is that RFID tags cannot be read through water, metal, or glass. So each product needs to go through extensive testing to find the optimal placement for an RFID tag. Here at the lab, we have 2 chambers and a large team that works to help companies optimize their tag placement.
The design of the RFID tag is often referred to as an inlay. These inlays are separated out into different categories based on what products they are optimized for. These categories are referred to as specs. The RFID lab helps your company find which specs are optimized for the products that you are trying to tag.
Thanks for tuning in to this RFID 101 video. We hope that it was useful in learning a little bit more about RFID and the Auburn University RFID Lab. Make sure you're following us on all social media and subscribe to our YouTube channel to stay up to date with the latest information in RFID technology and the Auburn University RFID Lab. Thanks.
Bye.